Hydrogen is the most abundant element in the universe and can be a safe, convenient energy carrier which holds tremendous promise as an energy-efficient and clean energy alternative. As a fuel, hydrogen is near ideal as it can be generated from a diverse number of feedstocks and can be converted to a desired form of energy without releasing harmful emissions at the point source, thus reducing greenhouse gas emissions. Hydrogen is the most abundant element in the universe, and mankind has been utilizing hydrogen for industrial applications for years. Storage of gaseous hydrogen requires heavy tanks, high-pressure refueling infrastructure, and this makes it inefficient because of storage limitations and also the hazards associated with the flammable gas. Large warehouse operations that utilize electric or propane-filled forklifts are an obvious candidate for utilizing hydrogen to fuel their fleet. Propane is also flammable, so there are obvious challenges with its use. Battery-powered forklifts can be safer alternatives, but still create challenges for industry. Battery-powered forklifts typically use a bay of lead-acid batteries to provide enough power for one 8-hour shift or 5 to 6 hours of constant use. However, one of the main disadvantages is the time required for the battery changeout and charging. On average, using an automatic battery changeout system, it takes 15 minutes for battery changeout and up to 45 minutes or more if it's done manually. Hydrogen-fueled forklifts represent an attractive alternative now that metal hydride beds have been developed to store the hydrogen. This allows hydrogen gas to be pumped and stored into the metal hydride material. To produce the power, hydrogen is desorbed from the metal hydride using heat and then converted into electricity in the fuel cell, which is then used to power the forklift. High-pressure storage systems presently in use on forklifts require extremely high pressures of approximately 5,000 psi. This not only requires expensive composite tanks, but also expensive refueling infrastructure that limits the adoption to mainly larger fleet sizes, maybe 65 and over, due to the cost. Technology that could alleviate those issues could have tremendous economic impact. The Urban Renewable Hydrogen Metal Hydride Storage System, originally developed by Hawaii Hydrogen Carriers and Sandia National Laboratory and being optimized by the Savannah River National Laboratory along with Greenway Energy, will reduce the barrier to acceptance. This system requires pressures of 700 to 800 psi, which is significantly lower than traditional 5,000 psi operation. This will significantly reduce the infrastructure cost in the near future and could allow the use of direct compression from solar electrolysis units, making the hydrogen less costly and totally renewable. As in any technological development, the cost to produce the low-pressure storage system is high initially. Pressure tanks that are in use now cost around $3,000, and the cost of the refueling infrastructure for this high-pressure system is around $100,000. Presently, these prototype low-pressure metal hydride storage tanks cost around $10,000. We feel that the lower-pressure systems will allow smaller companies to embrace the technology to fuel their industrial equipment, driving the adoption of these systems. Hydrogen, the most abundant element in the universe, will pave the way for the next industrial revolution.